Greetings, dear friends, fellow programmers, and those aspiring to be. I have a very tough question for you. Have you ever found yourself scratching your head, thinking about how might JavaScript execute asynchronous code? In this video, we will be unraveling JavaScript's event loop mechanism, of course, in a fun and exciting way. At least, I did my best to make it as fun and easy to understand as I possibly could, because the concept itself is a tough one to understand and get a firm grasp on. So, if you are ready and interested to master this very important topic of JavaScript, because at least in my experience, I encountered it so many times on job interviews, and I feel like people are asking it all the time because it really does show who really understands JavaScript engine and how it works under the hood, and who still needs to grow and learn in order to become an amazing developer. Because understanding event loop is going to make you 100% better developer, because you will demystify everything and know exactly what is going to be happening in your code, and that way you will prevent errors from taking place and also be much quicker on fixing the issues that may arise from your code. And now let us address the elephant in the room. How does JavaScript handle multiple tasks at the same time while being single-threaded programming language? It's a very common challenge within development world to understand how this is possible, because it might seem contradictory for a programming language that can execute only single task at the moment because it's single-threaded, to be able to perform asynchronous actions while handling multiple actions at the same time. One might call it magic. But in reality, there is an explanation for everything. So if you watch this video till the end and also combine it from the knowledge we shared in the previous two videos dedicated to call stack and event queues, you will be completely aware about everything that is going on under the hood whenever you execute any piece of code in JavaScript. Imagine the following scenario. You have multiple tasks that are running simultaneously in your JavaScript code, and you need to figure out an effective way to manage them at the same time. And JavaScript is, as we already mentioned, single-threaded programming language, so it can handle only one thing at a time. But thanks to event loop, JavaScript is able to perform multiple tasks at the same time, like responding to user inputs, to also handle network requests, or to basically provide functionalities for creating timers within our code, which are going to be handled while executing other stuff, and to allow us to do all of those things at virtually the same time. You can think about event loop as a backstage crew that is ensuring that everything is running as smoothly as possible on the concert, because the main star of the show is not able to think about all the things that are happening at any given moment. So that is exactly why they need this crew to make sure that everything is orchestrated as perfectly and flawlessly as possible. And your event loop does exactly that in JavaScript engine. But to be able to fully understand the concept underlying event loop, we first need to master the concepts of call stack and event queues. And in order for you to be able to follow along in this video, I prepared previous two videos explaining those two concepts. So if you did not see them, I highly recommend you to do that right away and then come back to this video and keep watching. So first, call stack is something like a to-do list in JavaScript. It contains all the functions that need to be executed at the given moment. And when the call stack gets emptied, so everything was executed, that is when event loop starts checking both event queue and microtask queue for any tasks that are waiting to be executed. And when some tasks are stored in one of those queues, they get picked up by event loop and pushed to the call stack so they can be executed. Understanding how this process works, like really understanding it, feels like peeling the surface of the puzzle and seeing what lies underneath, like the simple cardboard that is under the pictures of a puzzle, and when you see them, you know that everything under the picture that is the puzzle that looks complex is fairly simple and easy to understand. So let us go to a concrete example in our IDE so I can show you how the event loop and other underlying concepts play together. Let's see our first example of the day. And my friend, this right here is the simplest example of all the simple examples. We just have 3 simple functions which are just executed. Each function is just printing a single message. And this example can show you basically nothing spectacular because there is nothing complex going on under the surface. So what is going on is we first push the first function, call stack, it gets executed, then it gets popped off the call stack, then we push the second function, it gets executed, then we pop it off the call stack, then we push the third one, then finally it gets popped off the call stack. And that's everything that is going on. We just print first, second, and third function text one after the other. And that's exactly what we got here. But what I wanted to discuss in this example is the fact that event loop has nothing to do here, because we got nothing pushed on our event queue or Microtask queue. And that is why our event loop is just going to be idling. It has nothing to pick up from those queues in order to push it to call stack so it gets executed. But what happens when we need to handle asynchronous tasks, like timers or networking requests or things of those sorts? Well, in those scenarios is exactly when event loop is going to be very essential for the execution of our code. So let us discuss how it works. So when you do have those asynchronous tasks, like, as I mentioned, timers or network requests, they get pushed to event queue, and then the call stack gets emptied out and there is something lying around in event queue. Event loop is going to pick it up and push it to the call stack, and then the code will get executed as expected. And also, just to remind you about the concept of Microtask queue, which is where we are pushing the higher priority tasks, like promises in JavaScript, and they will get executed exactly in the same way as stuff that is put on the event queue, but with higher priority. So in order to show you all of this, I think the best way is to jump right into our IDE and discuss it via an example. So let's do just that. And right here we have a fun and easy to follow example. And as you can see, today we're making pasta. We have quite a few steps because I wanted to make sure that all the important concepts of event loop and underlying mechanisms are covered and shown in a very easy to follow and understand way. So I think the best way to get a firm grasp on what is going on here, we're going to jump to our drawing board and there explain every single line of code and what is stored in all of these data stores that we are using at each line that gets executed. So let's do just that. And welcome, dear friends, to our drawing board. It is time for us to understand the example I prepared for you by going step by step and explaining everything that is going on in all the underlying mechanisms of JavaScript. So, as you already know, we have call stack, which is responsible for executing our code. We have already known event queue, which is going to receive our set timeouts and tasks of that sort. And also we have a higher priority queue, which is called Microtask queue, which is going to receive all the promises which are then going to be picked up by the event loop, our main character of the story today, and pushed onto call stack before it pushes event queue tasks. So, to understand everything that is going on in code, I would like to go one line at a time and explain everything. Are you ready? I thought so. Let us go through our example, and the first line is going to be our console log that is going to state start cooking. And because it's a very simple action, it is going to be pushed onto call stack. And basically because it's simple, it's going to be executed immediately and popped off from the call stack. So it's no longer there. Now we are reaching our first set timeout action. So when we have reached it, what is going to happen? It is going to be pushed onto our call stack. I'm going to call it st1000 because set timeout 1000 milliseconds. And as you can see, it does have a delay that is set. So this means that this callback that is stored inside of the set timeout function is not going to be pushed onto event queue before 1000 milliseconds has passed. So basically what this means is that when this line right here, set timeout, gets executed, the callback that is inside of it is going to be floating around right here. I'm going to name it callback 1000 because it came from set timeout 1000 milliseconds. So it is going to float around here, and this we do not need anymore. It's executed and we do not care about it anymore. So next in line is going to be our first promise of the day. And inside of it, because it's already resolved, we do not need to wait for anything, which means that it is going to be immediately executed. I'm going to call it P1. So basically, the statement that is inside of then is going to be pushed on Microtask queue. So there it awaits for event loop to pick it up. So we are pushing our CB from P1 onto Microtask queue to wait there until it gets picked up by event queue. So that means that everything that needed to be done with our promise number 1 is executed, which means only one thing. We're entering our next set timeout action. So it gets pushed onto our call stack. And I'm going to call it ST0 because it has 0 milliseconds of delay, which means that when it gets pushed to our call stack, the callback that is stored inside of the set timeout function gets immediately pushed into event queue. So right here, we are going to call it CBT1, which stands for callback timeout 1. No, I don't like 1. It's going to be 0 because it's 0 milliseconds. Okay, so now that that has executed, we can cross this out because everything that needed to happen there has already happened. So that means that right now we are going to be executing our second promise of the day. And we're going to push it onto call stack, P2. And now, because it is already resolved, its callback from the then statement is going to be immediately pushed onto the Microtask queue. And when that is done, we are going to cross this out because we are done executing it, and we're proceeding to the final line of our code, which is going to be a simple console log for ending our session of cooking. So we're pushing it, and basically because it's simple, we can just cross it out because it's done, it's executed, and basically that's it. So when that is done, we went through our entire code base and we have explained everything that was going on. So right now, what is going to happen? Our event loop is going to take a look at the call stack, see that it is empty because everything that needed to be executed was executed. So it will start taking stuff out from our queues. So the first thing that is going to be taken is going to be this one. Because as you remember from our previous lesson, queues are first in, first out architecture. So that means that the first thing that was pushed on the queue is going to be the first thing that is going to be popped off from it. So our callback for promise number 1 is going to be the first thing that is going to be pushed onto the call stack. So its callback is going to be executed. And now we are basically executing the console log action from this callback, and after that, we are just crossing it out and popping it from our call stack. So it no longer exists here, neither there. Now, next in line is going to be our second callback for second promise, so it gets pushed onto our call stack. So we are going to write here callback P2, and now we are going to print that message as well. And when we do that, we again cross it out from call stack because it's executed. We also have popped it from our Microtask queue, and we are completely done with all the stuff from our Microtask queue, which means that our event loop is now going to take a look at the event queue. So when that happens, it will find only a single callback, which is for our timer with 0-second delay. It is going to take it and push it onto call stack, and we're running out of space. So it's callback timer 0, and it will be executed. So we have popped it from our event queue. It will be executed, and when that happens, we're going to receive the message and just cross this out from our call stack. So basically, our event loop is going to, from time to time, check both Microtask queue and event queue to see if anything has changed or any task has appeared there. And after 1000 milliseconds has passed since this callback was popped from our call stack, when we executed this line right here, so from that moment we are counting 1000 milliseconds, and when that period has passed, this part right here will be pushed onto our event queue, waiting to be executed. And when it gets pushed into the event queue, event loop, on its next check of the event queue, is going to see that it has stuff to work with, and then it will just push it onto call stack, and then it will print that message as well, and after that we will be done. Everything will be executed, which means that this right here was crossed out and popped from our event queue, pushed onto call stack, printed the message on call stack which was inside of the callback, and then it crossed it and popped it off from call stack. So this was everything that went under the hood in our JavaScript engine and all of its underlying organizational parts. And now that we managed to successfully go through all the steps, and first of all, I would like to congratulate you for sticking around to go through all of those, because there are a few. I would like to try running the code and see that we get exactly what we expected on our drawing board and confirm it in action. So let me run the code, and as we can see, we managed to get exactly what we expected. We first get start and finish lines, followed by 2 promises for chopping and preparing, and finally we get the 2 that were landed in event queue, but we get first cooking pasta because it had no delay, and finally we get boiling water because it had to wait for 1000 milliseconds. So we just confirmed that our execution path that we draw on the drawing board seems to be exactly right. Which is always a nice thing to have. I mean, it would be very embarrassing if we got a different result and we just wasted all the time on the drawing board. And right now comes the climax. If this was a novel, this would definitely be it. So right now that we just took a very deep and intense dive into JavaScript engine and its underlying mechanisms, it is time to just go out and say it that event loop executes tasks in a non-blocking, asynchronous manner by utilizing event queue, microtask queue, and call stack mechanisms to make it happen. And also, it ensures that our code runs smoothly and without any hiccups. Basically, it effectively manages tasks that are stored on the event queue and microtask queue, and it pushes them to the call stack when the call stack is empty, that way making sure that everything that is ready to be handled gets executed right from the call stack. This seamless integration and collaboration allows JavaScript to handle multiple tasks concurrently without blocking the main thread, so our application is able to listen to user inputs, networking requests, or to handle whatever it is we need in our application and make it work exactly like we want it to and behave like a multi-threaded application, even though it is not. It is just a single-threaded application that can execute a single action at a given moment. To wrap things up, understanding event loop and other underlying concepts is definitely a core thing you must invest your time and efforts into mastering, at least if you want to be a really good developer in JavaScript. If you would like that, which I sincerely hope is the case, I think you're on a great path. If you have any questions or concerns about the stuff I presented to you in this or the previous videos, please do feel free to leave your comments with concerns, questions, additional information, additional explanations that might be a better way to explain these concepts, because I would really like to see and hear your feedback on the topic. And until the next video, I would like to invite you to subscribe to the channel, at least if you found the content of this video useful, because the content I tend to provide is of this quality and this kind. So if you enjoyed this one, you definitely should consider taking one step and subscribing to the channel, because you will find a lot of very beneficial stuff in the near future. Thank you for watching and happy coding!